Hi and welcome guys, this is JNM with a Learning C++ tutorial for beginners. This is the first part. More parts will follow because you guys gave me the feedback that there's a huge interest in learning this programming language and programming in general. So let's get started. These are the topics that I want to talk about. First I want to give you a very short introduction what C++ is, where it comes from, and also what a compiler or a linker is. After that, I suggest two development environments to create C++ programs. With one of these, with Visual Studio 2017, we are going to create our first C++ program, then a console application. After that, I will explain concepts like variables, functions, header files, or aggregate data types. It's important to understand these basics before creating your own applications. Alright. What is C++ and where does it come from? Well, first there was the language C, a highly efficient language developed 1972 by Dennis Ritchie. The language is platform independent, can be compiled on different computer architectures, and it is standardized by the American National Standards Institute. The last standard is C99. The Danish computer scientist Brian Stroustrup started 1979 to invent an extension to this language he called C++. He added new features to it. One main feature is the object-oriented programming and other concepts that makes it extremely powerful. Nowadays we have new standards for C++ like C++ 11, 14 and 17, which are partly implemented by modern compilers. So I mentioned compiler. C and also C++ are compiled languages. A compiler is a program that converts instructions of a language into another one, like the machine language, that can be understood and executed by a computer. For C++, the source files that you write are converted by the C++ compiler into so-called object files. An object file contains object code, machine code that is not executable. It is the linker, a program that combines the object files to an executable file. I won't go too much into detail for this, I just want to let you know what basically happens when we later on compile, link and execute our programs. You will barely notice these processes because the IDE will hide it as good as possible. But what is the IDE? It is a shortcut for your integrated development environment for programming your C++ applications. I want to suggest and recommend two IDEs here, which are free for download and in my opinion let you create your C++ programs in a very comfortable way. The first one that I want to mention and that I personally use is Visual Studio, now in version 2017. You can download the free community edition from visualstudio.com/downloads, and it comes with the C++ compiler from Microsoft, which supports C++ 11, 14 and some features of C++ 17. But you are free to choose the compiler that you're actually going to use. It has to be installed on a Windows OS, but there are efforts to make it available for Linux as well. Another great and free IDE is Code Blocks, which can be used for Windows or Linux out of the box, and you have a free choice for compiler usage. The IDE is very lightweight and fast, and it can be downloaded on codeblocks.org/downloads. If you use Mac OS, you can use Xcode or the Eclipse IDE. Okay, enough words and introduction, let's create our first C++ application with Visual Studio 2017. Press New, Project, and now we have quite a few project types that we could create. Let's choose a simple one, a console application that starts a standard command line console. To that we can add standard in and output. I will call this calculation app because we're going to implement some mathematical functions. Then I press OK. The next dialog I also leave as is. Press Finish. And the skeleton for our first C++ program is created. So this file contains the skeleton of the application with one main function, which is the entry point for the application. So this is the first function that is called when the program starts. And when the program terminates, it returns 0, which means okay, everything was correct. Now when I press this local Windows debugger, I start my program. I will explain what a debugger is later on, but then you don't see much. It is compiled, linked, everything is done in the background, but the console isn't visible because it is started and closed. Now let me add a few lines of code to prevent this closing of the console. You won't understand this now, but you will later on when I explained the functions and concepts. What I do here is I will print out something to standard out high from my first app, then I let the user input something which prevents the console from being closed. When I start my application now, you can see the console, here's the output, and then I have to press a key to let the program run again and finish. We will work with this console application to explain all the following concepts. The first one is variables and namespaces. So what are variables? Well, basically these are just data items in your computer's memory. So let's define a variable of type integer and initialize it with a value. The data type is int. Then I give this variable a name like number, and then I assign the value 10. So this is essential. Always initialize a variable because otherwise it is in an undefined state which could lead to unpredictable behavior. An integer is a number without a fractional component. It can be positive or negative. There are many other data types, for example floating points like this double that I just defined. And as you can see here, I didn't assign a value. I didn't initialize it, but I should. And I name the double value d number for double and the integer I number. Here I wrote a command that this is not initialized, but I will do this now and assign 5.0. An assignment of a value to a variable can also be done after it is defined, but you should always initialize it. This means set an initial value directly after the definition. Okay, now let's define a second variable of type double, and I call this d number 2 and set it to 50. Now let's use an arithmetical operator for these two double variables. So let's add d number 2 to d number and store the result in a third variable called result, also a double value. So let's print this out in the console window. We use C out of the STL library, which we don't know yet, but I will explain this later on. When I start the application now, you can see the output, my result, 60. These variables are defined in the main function, but we could also define them outside of this function. Then their so-called scope is not the function, it is the whole file. The problem is here, if somebody defines a d number or d number 2 variable in a different function of this file, then you have a collision of the names. The compiler wouldn't know which variable to use, or it would override an existing variable and you don't know which variable is currently used. This could lead to extreme confusion, so don't use global variables. One feature to make variables or functions or other things unique in C++ is to use namespaces. So let's put these two variables in a namespace and call this, for example, number space. You can call this whatever you like. Now these two numbers are not known anymore in the main function. To use them, we have to specify the number namespace. So let's specify it for these two variables. Just write down the namespace. And then you can see in the IntelliSense of the IDE that these two variables are defined in this namespace and you can select them. Another possibility to use the namespace is the using statement. You can write in the scope of this function or also outside using namespace, number namespace. And now these two numbers, dNumber and dNumber2, are known and valid, and we can compile and start the application. And now I have a closer look at this std. This is just the same, a namespace that is defined in the library STL, the standard template library. We state the std namespace here explicitly, but we could have also used the using statement to include this namespace. Okay, let's come to a new feature called functions. Sometimes you want to use a functionality like to add two values or hopefully more complex tasks many times in your program, but you don't want to write the code over and over again. This is where functions come into play. A function can have a list of parameters and can return a result. So let's turn our addition logic into a function. We define it, the result should be a double, the name is add, and it takes two parameters, also of type double, value 1 and value 2. And now in curly braces we implement the function. This is the same code that we wrote in the main function. Let's add these two values, store it in a double and return this double. We can write this as one line. Okay, here's our function, now let's use it. We can get rid of these two definitions and call the add function to get the result. Then I press F5 to compile and start the application, and here's the result as before. Now how about moving this add function to the end of the file? Let's compile, and this doesn't work. Add isn't known anymore. Well, this is the case because the compiler evaluates the symbols, the declared functions sequentially from the top to the bottom of the files. But there's something very interesting you could do in C++. You could use a so-called forward declaration. You tell the compiler, hey, there is an add function and it looks like this. It will return a double, it has two double parameters and the name is add. And now we could implement this function wherever we want, for example in a different file, and use it here in our main function. Isn't that cool? Now this function takes two parameters and returns one result. But how about a function that has more return values? For example, you want to know if the operation was successful as a bool parameter. That could be true or false, but you also want to return a result, like for this division here. So this function, for example, takes two parameters, value 1, value 2. It returns if the division was successful, for example division by 0 is not possible, and then we define a result as a parameter. But now you ask, how could a result be a parameter? Well, we use this ampersand here to define it as a so-called reference. Now if I pass a variable to this parameter and change the value of this result inside of the function, it is also changed for the variable that I passed. That's the difference of passing a variable by value without the ampersand or by reference. If I pass by value, then a copy of this variable is created, and inside of this function I work with a copy. So if I change this parameter, it has no effect onto the variable that I passed as parameter. So in this division function here, I check if the value 2 is 0. If this is the case, I return false because this won't be a valid division. But if it is true, I divide value 1 by value 2, store the result in the reference, and return true. Now when I call this function, I could evaluate if the result is true, if it is successful, and then I know that I have a valid result for this division. Otherwise, I could, for example, print out that the division was erroneous. So let's first start it with a valid division. Result is 2. Then I will divide by 0, and this leads to an error. Okay guys, now let's come to header files. I showed how to use a forward declaration for a function. We did this for the add function. Now let's do the same for the div function, for the division. So I move the implementation to the bottom of the file and then add the declaration here below the add function. Okay, that's nice, but what I really want to do is I want to include these two functions, the declaration of these functions, like I did here for the std afx or the IO stream. You can include a header file by using this include keyword and then the name of the header file. And this is really handy because we can include these functions wherever we want, but we don't have to add the declarations all the time. We just have to include a header file. So let's add this. Here in the header section, select header file and give this a name, like for example, math_ops. Okay, here's this pragma once to ensure that the file is included only one time in a file. I will explain this in a later tutorial. For now we just use this pragma once and copy the declarations of add and div to this header file. Just copy and paste, and here we go. Okay, and now you guess it, just include this header file instead of forward declaring these functions. Include math_ops h. And that's it. We can compile and start, and it will work as before. Great, so let's move on. How about moving the implementation into a separate C++ file? Press New Item, select C++ file, and name this math_ops cpp. And again, we just copy and paste the add and div implementation to this file. Okay, what we also have to do, but this is related to Visual Studio and an internal that I'm going to explain in a later tutorial, we have to include the std afx header file into this cpp file. For now, just accept that we have to do this. As I said, I will explain this when we come to pre-compiled headers and optimizing compile times. Alright, now again we can compile, start the program, and it works as expected. We have a very clean main function. We included a header file and added the implementation to a separate cpp file. Great! But now these functions, add and div, are global. Somebody could, for example, define this in a different header file, and then we have a name collision. But we know the concept of namespaces, right? So let's wrap these two functions, add and div, in a new namespace and call this, for example, math functions. We have to do this in the header file and in the implementation. And now calling div or add in the main function as we do it is not possible anymore, because we have to specify the namespace. So let's do it. Math functions, double colon, and here we have add and div. This is like a first step of creating a library, a function library. Seems like everything fits into place if you know how and what to do. So let me come to the last feature of this tutorial. This is aggregate data types. An example for this are structs. These are user-defined data types that are used to group information. For example, a point that I declare here in 2D space has an x and a y variable. So after I declared this point, I can use it. like I do for any other variable, for example for these doubles. I just write point, define a name for this, and then I'm able to initialize the x and y variables. So that's cool, but wouldn't it be better to declare this point in our new header file, in the math operations? Because then you can use it wherever you include these mathematical operations. So to summarize, including this header file brings us a namespace with new data types and functions. In the end, let me write a calc distance function that makes use of this new data type point. And of course it is declared in the header file and implemented in the CPP file. Well, for calculating the distance, I need a square root function. So if you know the library and the header file where it is located, you can just include it here to the std afx, and this is also in the STL library in the header cmath. The namespace of the STL library you already know, this is std, and here you have the square root. As a parameter, I think, school's over for a long time, the power of the div x plus the power of div y, and now we have a function in our new library to calculate the distance between 2 points. And of course we can call this in the main function or wherever we include this. Okay guys, I really hope you liked the first part of the Learning C++ tutorial. In the next one we will move on to precompiler directives, object-oriented programming, and the standard template library. Please don't forget to subscribe to my channel to be up to date when new tutorials arrive. Thanks for watching this, and see you soon on JNM.